All right, in this last little short video talking about thermodynamic changes of phase equilibrium, we're just going to talk about a little bit of some criterion to describe a phase transition. Okay, so there are two types of phase transitions. There's considered a first order phase transition. Okay, examples of these, right, are your melting, your freezing, vaporization, sublimation, right, these things like that, right? Okay, in these changes, right, the molar volume, enthalpy, entropy, right, they all change, right? But some of the things that you can notice is that the derivative of the chemical potential with respect to temperature or pressure is discontinuous, right? Because again, if you remember, we had those plots of chemical potentials versus temperature, right? If you plotted mu versus T, right? You had your solid and you had, your liquid, right? Right. So at this point, right, the slope is different at this phase boundary between the solid and liquid, right? While the chemical potentials are equal, their slopes are different. They're discontinuous. Okay. Right. And then, and again, this kind of trying to represent the stuff down below, right? You have some net change in molar volumes, net change in entropy, right? The chemical potentials are the same, but their slopes are different, okay? Right? And then also the heat capacity is discontinuous and it's infinite, right? So the heat capacity between the solid and liquid, for example, is different, right? So that does change, but at the phase transition, that heat capacity becomes an infinite quantity, right? Because at phase transition, no matter how much heat you put in the system, the temperature does not change, right? And so that means you have like this infinite heat capacity. Okay. So I'm going to look at then a second order phase transition. Okay. So these transitions are a little bit more subtle. These are things like a solid transitioning between a conducting and a superconducting solid. Okay. So in these cases, there is no change in enthalpy, molar volume, entropy. Okay. Now the slopes of these things are discontinuous. Okay. Right. The molar volume has kind of this discontinuous slope, enthalpy. Right. Now for chemical potential, the chemical potential is still continuous, right? The slope of that chemical potential is continuous, okay? And then heat capacity is no longer infinite, right? It is now finite, but it is discontinuous, right? The heat capacity does still change between those two phases, but it no longer blows up to infinity at that phase boundary, okay?